Hi students, this is Miss Clifton coming at you this morning. I wanted to make my own matrix multiplication video, recognizing that this one is quite tricky. So we're going to go through selected problems of assignment 8-7. And here's the first one I've selected, 27. So on 27, go ahead and write down the matrices, but don't write them down like this. Don't write them down next to each other the way the book gives. Even though the videos in the past, like yesterday, did this this way, I think there's a little bit easier of a way. And that's if you write the second one elevated like this so that the corners of the two things are touching. Now it seems arbitrary, but if you do write it so that the corners are touching, I think you're going to find that this gets a little bit easier to keep track of. The reason is because of the order of each matrix. Now, order means dimension, and so we always measure the order for the dimension as rows by columns. So the number of rows in my first matrix is 3. The number of columns is also 3. So this is a 3 by 3 matrix, as is this one over here, 3 by 3. So not all matrices are multipliable. It depends on their orders, and here's what it depends on. If the second number in the first matrix matches the first number of the second matrix, then you're good to multiply. And if they don't match, then it's undefined. It's impossible to multiply. And then here's how the result matrix is going to work out. The result matrix is going to look like this. And that's why I had you move it up a little bit. Because, see, it fits perfectly. The number of rows over here is going to indicate what happens moving forward. And the number of columns over here is going to indicate what happens moving forward. So it's nice when you set it up like this that you kind of have slots to put your answers in. By the way you can know how big your answer matrix is going to be is it's those other two numbers that I didn't highlight. The first number of the first order and the second number of the second order. So 3 by 3 is going to be the result matrix. Okay, here's how multiplication works for matrices. It is not intuitive. It is not what you would expect, but now that you're being taught it, you will be able to do it. So we're going to get, in a 3 by 3 answer, how many answers, how many little entries? An entry is an individual answer. We are going to get 9 of them. So just for now, I'm going to make this look like a tic-tac-toe board so that you can see the separation between my 9 entries. But you don't have to do that. It's optional. It's just so that you can keep track easier. And then this is going to get messy, so I'm actually going to write my real result over here. I can spell. And that's going to be size 3 by 3, like I said before. Okay, so here is the first step to multiplying a matrix. If you want to fill in any particular entry of your 9 parts of your answer, so let's say this is the one I want to fill in first, you take the row that leads to that spot and the column from the second matrix that leads to that spot, and you multiply each entry, each corresponding entry together, and you add all of those products. So here's what I mean by that. Looking at row 1 times column 1, you look at the first entry times the first entry. 3 times 1 is 3. Plus, you look at the second entry times the second entry. -4 times 0 is 0. Plus, third entry times third entry. 3 times 0 is 0. Okay, so that means that we have an answer for the first spot of our matrix. It's 3. 3 plus 0 plus 0 is 3. On to the second one. I'm going to leave this row and I'm going to move over to the next column because if you can see, this leads here and this leads here. So if I want to find that answer, I find this first row and the second column's products. This times this, 0, plus this times this, 16, plus this times this, 0 again. Okay, one more time and then I'll be done with this first row. You guessed it, we need to use the third column because it naturally flows here if you wrote it corner to corner. So we've got 0 times 1 plus -4 times 0 plus 3 times 1 is 3. Okay, so moving back over to my neat answer matrix, the results so far are 3, 16, and 3. I'm going to pause the video and do the next 2 rows and come back to you. So please try that yourself, and I'll try to explain anything that I don't explain while I'm paused. The next 3 ended up being 0, -32, 0, and the last three end up being -6, +4, 5. You can see that zeros are our friend. This would have been a lot harder to do if there weren't so many zeros in these two matrices. But yeah, I went each row of the first matrix times each column of the second, all the entries added, all the products added, and this is my final result. So moving on to the next problem, 39, it says write a matrix equation equivalent to the system of equations. So it's not asking for what we already learned how to do, how to represent a system as a matrix. We already learned that in 8.5, but what it is asking for is a matrix equation. We're not going to even solve this equation today. We're not ready, but this is just your first chance to see what it looks like to write a matrix equation. Here's what it's going to look like. It's going to be a 2x2 matrix, which we're going to call our coefficient matrix, times a 2x1 matrix, which we're going to call our variable matrix. And since it's an equation, there is an other side. That other side has an equals 2x1, which we're going to call our constant matrix. So this matrix equation that represents a system this time is going to be a coefficient times a variable equals a constant. You're going to put all your coefficients in. You could probably guess the way we're going to put them in. 2, -3, 1, 5. You're going to put your variables in. X is on top, Y is on bottom. Constants on the other side. And this is the answer. This is the answer, but let me just make sure you understand why it makes sense, why it really does represent that equation. So if you multiply the coefficient times the variable matrix, and I would do that by moving this whole thing down. Let's see if I can not mess it up. There it is. Move it down. Okay, so this would be row times column, this part together and that part together and added. So it's 2x plus -3y. And then if we do row times column again with the second row, 1 times x plus 5 times y, 1x plus 5y, and then equals, let me bring down the 7, -6. Do you see what this is saying? This is saying this entry and this entry equals this entry and this entry. That means 2x minus 3y should equal 7, and x plus 5y should equal -6. That's what we were told at the beginning of the problem. So just rest assured that the answer that we wrote, the answer that I told you a second ago was the actual answer, really does represent the matrix equation. Again, we did not figure out how to solve this today. We just figured out how to write the matrix, and that's as a coefficient matrix times a variable matrix equals a constant matrix. All right, last problem that I want to do today. I don't even remember what number this is. I don't know. You're going to have to look it up yourself. Last problem I want to do today, it says, given a and b are that, show that a plus b times a minus b is not equal to a squared minus b squared when we're talking about matrices. So usually this is true. Usually a times a squared, a times b, -ab, plus ab, minus b squared. These guys cancel. Usually this is accurate, that it does equal a squared minus b. But you're going to see, as the textbook implies, that this is not true when it comes to A and B standing for full matrices. So I've set this up as we were supposed to see it. We were supposed to see A plus B times A minus B and see if it equals the same thing as A squared minus B squared. So I think you can do most of this on your own. So I'm going to stop the video here, and you guys can check the answer key for the rest of it, the answer key on my website. Good luck. See you tomorrow.